Hi, I'm Susan Evans from susanevans.org, and today we are doing a physics experiment called the speed of a rotating cookie. First, you will want to make a big, ginormous chocolate chip cookie. Take a look.
We are making chocolate chip cookies. Start by cracking one egg. Three-fourths cup of granulated sugar, or ordinary sugar, and then 3/4 brown sugar, and then 1 cup of margarine. Ooh, the gooey. Now stir. Now add 2 1/4 cups of flour. Add 1 teaspoon of baking soda and 1/2 teaspoon of salt and stir. Now add 2 cups of chocolate chips. Yummy, 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 yummy. Now get a pizza stone and just splat the whole thing like a meteorite. A little bit too sticky for a meteorite.
I don't know if it's too much. It's still going. Don't mess it up.
That's good.
I think it's too much for one cookie. We'll split it. Let's see.
Oh, let me do it. Let me do it.
Wait.
Film it on camera.
That's too thick.
That's good. Spread out half the cookie batter. You might want to use a spatula. And then preheat your oven to 375 degrees and place it in and bake it for however long it needs to be.
At least 10 minutes.
Yeah, at least 10 minutes, and hope it doesn't burn.
While we are waiting for the cookie to bake in the oven, I'm going to talk about the speed of an object that is circular that rotates. A perfect example of this is a merry-go-round at a park. Take a look at how we calculate the speed of something that is rotating. Here we are at a park with a merry-go-round. Now we are going to measure the radius of the merry-go-round with a tape measure from the center
5 feet
to the outside. So how much?
5 feet.
5 feet. Okay, so exactly 5 feet or 60 inches. All right, now what we're going to do is we are going to spin it and count for 15 seconds how many times it can go around to figure out the speed of the merry-go-round. Okay.
The bar, not her.
Now we are going to time 15 seconds and count how many times Rachel goes around. Ready, set, go! 1, 2, 3.
Stop.
Oh, 4, almost 4. Okay, almost 4 revolutions. So maybe 3 3/4, so 3.75 maybe?
Now you can.
So we measured the radius of the merry-go-round, and that was 5 feet, okay? So the circumference, which is the around the entire circle, the circumference is 2 pi r. So that's 2 times pi, which is 3.14, times r, which is the radius, which is 5 feet. So if we do 2 times 5 is 10, times 3.14 is 31.4 feet. Okay, so 31.4 feet is the distance around the outer edge of the merry-go-round. Now, when we calculated how many times Rachel went around, we timed 15 seconds and we saw that she went around almost 4 times. It was really more like 3.75. And so in 15 seconds per minute would be times 4. So we have 3.75 times 4 is 15 revolutions per minute. So in 1 minute, in 60 seconds, she would have gone around 15 times. Okay, so 15 times in 1 minute with a distance of 31.4 feet, okay? You multiply those two together to get 471 feet per minute. So, going the same speed that Rachel was going all the way around, it would be 471 feet that she traveled in 1 minute. Take a look as we take the cookie out of the oven. It's been 14 minutes and it looks like we put it too close to the edge, okay? So make sure that you put a cookie sheet underneath. Some of it is fine all the way around, and then on one edge it was going over. So make sure you leave maybe a little bit less than an inch on each edge to allow for spillover. If you want, you can use just a few M&Ms. You could put one red M&M in the middle and then maybe a blue M&M off to the side, and the rest of it not be a chocolate chip cookie. That's not what we opted to do. Instead, what we're going to do is we stabbed a little toothpick that looks like a sword. We put a green one on the outer edge of the cookie and a yellow one on the inner edge of the cookie. Now, we are going to see how fast this one rotates and how fast this one rotates. Which one is actually moving more? Which part of the cookie is moving more when you turn it? Now, you can put the actual cookie on wax paper. We have opted to put the entire cookie like this to not break the cookie. We've also put something under it, like a pot stand or something like that. So we are going to spin it, and you at home, I want you to pay attention. Is the outer part going faster or the inner part? Ready, set, go. Woo! Okay. See how the green is going way around. Okay, now the yellow one, you see how it's hardly moving at all? Okay, compared to the green. Okay, so this shows that the outer part of a circle moves faster than the inner part of the circle. Just as if you are on a merry-go-round, if you're on the outer part, you're moving way faster than if you are on the inside part. If you would like to figure out the speed of your rotating cookie at home, if it's this big, it is half a foot. Okay, so this is 1 foot, and then half of that is the radius. So 2 pi r, 2 times 3.14 times half a foot. If you want to do it by inches, that's 6 inches. So you can multiply that out at home to find out the circumference of your cookie. Then when you spin your cookie, you can time it for 15 seconds to see how many times it goes around. Let's say it goes around 5 times in 15 seconds. Well, in 1 minute, you would multiply that times 4, because 15 minutes times 4 is 15 seconds times 4 is 1 minute. Okay, so if it goes around 5 times in 15 seconds, 5 times 4 is 20. So it goes around 20 times per minute. Okay, so you take the 20 and multiply it times the size of your cookie, your answer for that, and you will get the speed of your cookie. Isn't that cool? I'm Susan Evans from susanevans.org. Thanks for watching.